everyone, I am Renu Sharma, Assistant Professor, Ajay Kumar Kark Engineering College. Today I am going to start with the next topic of the subject, that is data communication network. Its code is KEC 063. So, the topic of today's lecture is HDLC and point to point control. So, that is related to data link layer. So, if you remember about the data link layer, that is a part of a OSI model. So, earlier when I have started with the data communication network, then I have discussed about what is communication, then what is data and how the network is formed, so that the proper communication between the nodes will take place. So, for that we have also discussed that all the information that is transmitted is in the form of layered architecture is there, or you can say that it is layered task. So, this layered task is basically divided into two types of model. That first one is the OSI model, that is open source interconnection model, and second one is TCP IP model. This we have discussed earlier. So, why I am discussing here, because I want to show the connection with the data link layer. In case of this OSI model, there are 7 layers, and these 7 layers are, first one is the presentation layer, then data link layer, second layer is the data link layer, then network layer, transport layer, then session presentation, followed by the application layer. So, these are the different layers that are available in the OSI model, whereas in case of this TCP IP model, there are 5 layers. So, here it is 7 layers and that is reduced to 5 layers in TCP IP model. So, in this lecture we will discuss about HDLC, that is high level data link control, its frame formation, what is HDLC, all about HDLC, how the frame will be formed in this HDLC, and then point to point packet transmission we will discuss. So, this is HDLC. The full form of HDLC is known as high level data link control, and it is a bit oriented protocol for communication over the point to point and multi point link. So, in this one line definition, you can say there are 3 to 4 different terms that are used. First thing is that what is bit oriented. So, previously I have discussed about two types of transmission that are possible, bit oriented and character oriented. In case of character oriented, we have to transmit the information that is in the form of words, characters like A, B, C, D, alphabetically alphabets we have to transmit. But in case of bit oriented, it is basically oriented in terms of bits, means we have to transmit the data in terms of 1 and 0 form. And in case of this character oriented, we have to transmit the data in the form of characters only. Okay, so, this is high level data link control is nothing, it is a bit oriented protocol, and it is possible for communicating over point to point and multi point links, means in both type of transmission it is possible. Now, what is point to point and what is multi point link? Let us say this is a network that has set up, and there are 2 nodes are there. This is the transmitter and this is the receiver part. Okay, so, it will going to transmit the information in this direction. Now, this is known as point to point link, where only 2 devices are connected together for the purpose of communication. There is no third point is available, or you can say no third device is available for the purpose of transmission. Now, next one is the multi point, where there is only one transmitter and there may be more than one receivers are there. So, that is the case for multi point. So, you can see that in this single definition we have seen that HDLC is nothing, it is a bit oriented protocol and it is suitable for transmission for point to point and for multi point links, and it is implements the ARQ mechanism. What is ARQ? ARQ is nothing, it is the automatic repeat request. So, whenever we are transmitting the information and we have seen that the acknowledgement has not received after a particular time interval, then it has, the transmitter will sense that the acknowledgement has not received and it will going to transmit the data from the transmitter side again. So, that is known as automatic repeat request, means after the timer has time out, then it will going to repeat, it will take the step that either the acknowledgement has received, or if the acknowledgement has not received, then it will going to transmit the data again, the packet will be transmitted again. Now, this is the normal response mode, that is related to the HDLC. You can see that this is a point to point link where a single primary and a secondary device is connected. Now, what is primary and secondary? Primary is the one which will going to initiate the transmission, which will going to generate the data for the purpose of transmission, and it will going to initiate the communication. So, that is known as the primary device, and there are more than one secondary devices are available, but in this case, that is the normal response mode point to point, only one secondary device will be there. The number of secondary devices will be 1 and primary device is exactly it is 1. Now, you can see that a command will be transmitted, or you can say that whenever I want to, let us say a secondary device is a printer and I want to take a printout of a particular email, then I will send a command to take the printout from the printer. So, this is a kind of command, or you are asking for something, some application that has to be done, performed on the secondary device. So, that is a command, and in response, in this situation where I want to take the printout, the printer will going to print out that particular document. So, that is the response. Or if I am transmitting particular kind of information in let us say in terms of packets or frames, then acknowledgement will be received from the secondary device. So, that is the case for point to point transmission. Now, next is the multi-point. You can see in case of this multi-point, there are two secondary devices are connected, and this is not restricted to only two devices. There are more than two devices. Let us say it is more than one device you have to connect in the at the receiver side, means more than one secondary device you have to connect, connect to this primary device. So, this is how the command will be set up, or the command will be sent to each of the secondary device, and in response to that particular command, a response will be sent back to the transmitter side. So, this is known as the normal response mode. So, this is very simple, a command response operation will be done between the primary and secondary device. Now, next we will see asynchronous balance mode. In this asynchronous balance mode, if you see that this is a combined operation. Combined means it will act as a primary and it will act as a primary, or it will act as a secondary at the same point of time. You can say that it is a kind of full duplex communication, because the same device can transmit and it can receive at the same point of time, and also this combined is all known as it will act as a primary and it will act as a secondary device. So, this is the combined meaning which is used over here. Now, you can see that command and response, if it is working as a primary device, then it will going to send a command to this device, and if this is working as a secondary device, then it will send a response to the command which is sent by this secondary device. So, this is how the work will be set up in this asynchronous balance mode, means balancing is being maintained for the purpose of transmission, so that the communication will take place at a with a better quality, and also it will maintain the balance, means if one device is working as a primary, then automatically the second device will work as a secondary device. Now, next is we will see that how the information will be transmitted in case of HDLC, in case of frames. Now, the main aim, or you can say the main work of the data link layer, which is a part of this OSI model, is to form the frame. How the frames are formed? In the most simplest form, if you will see that this is the data which you want to transmit to the next layer, then this is the header part and this is the trailer part. Okay, so, this is in the simplest way, this is known as a frame. You have formed a frame by adding the header information and by adding the trailer information. Now, this header information what it will consist? It will consist of the source address, it will consist of destination address, and there are different types of addresses. If you know, if you remember that logical address is there, physical address is device specific, means for a particular device, for a particular, you can say a printer, different printers have their own physical address, different computers have their own physical address. So, that is physical address, logical address is there, port address is there, and also there is application addresses are there. So, this is an example of different types of addresses. So, this is how you have to form a frame where the data is been there and it is headed by a header and it is ended by a trail bits. So, this is how the frame will be formed. Now, you can see that there are 3 different types of frames are there, like first one is the I frame, then S frame and U frame. So, what does it mean? You can simply see that in first go, if you see that there is a difference in point from here to point here. Okay. So, this is how you can segregate these 3 frames, like first one is the I frame, which consists of the user information along with the frame check sequence. What is FCS? FCS is nothing, it is the frame check sequence. Frame check sequence means if I have transmitted the data in terms of bit, because HDLC is bit oriented. So, I have to transmit the data in terms of bits, and if somehow the bit information has been changed or there is some problem, there is error, then frame check sequence operation will be performed at the receiver side. It will going to check that in which particular bit the information has been is in problem. So, this is how the FCS will work. Now, you can see that all the 3 frames are having their different construction, and you can see that this consists of user information and FCS, this consists of FCS, and U frame consists of management information along with the FCS. Now, this is headed by a flag information, address is there, control information, and ended again with the flag. In case of S frame, there is a flag, there is a address control, and then it is ended by flag again. Then in case of this U frame, there is a flag, then address control, and it is ended by a flag again. So, this is what this HDLC, this is how this HDLC will work. HDLC different types of frame will work, like the I frame, then S frame is there, then U frame. In case of this S frame, if you see that there is only frame check sequence information will be available. In case of this U frame, there is management information that is related to how to manage the different packets that will be transmitted. So, this is how these 3 different types of frame will work. Now, next is the control field format for different frame types. So, what is control field format? For the different frame types, different frame types means I frame, S frame and U frame. If you have seen in this previous slide that a control field is there, which is the third field, and this is different for each of the frame, means you do not have to transmit the same control information in any of the frame, like the I frame, S frame or the U frame. You have to transmit the different information in each of the control part of control field of each of the frame. You can see in this case, this is the I frame, its construction, or you can say the format is somewhat looks like this. This is 8 bits of information, means all of this is 8 bits. This is also is of 8 bits, then this is also 8 bits of information. So, first frame will be the first bit of this frame will be 0. Next you can say in case of this S frame, the first 2 bits are 1 0. In case of U frame, the first 2 bits are 1 1. So, this is how you can differentiate. This is how you can differentiate that, how these frames will be differentiated, like I frame starts with 0, S frame will starts with 1 0 and U frame starts with 1 1. And then this is the code that you want to enter, this is the green color shows that you have to enter the code, then P by F information you have to transmit in this control field. Now, you can see that this is the U frame control command and response. This table is showing that how this U frame information control and command you have to enter. Like if you can see that the code starts with 0 0, then 0 0 1, then it can also start with 1 1 or 0 1 1, then 1 1 1 0 0. This is the command statement. Like if you see it, this means this is set normal response mode, SNRM. This is set normal response mode. So, two types of modes. First we have discussed normal mode and the asynchronous mode. In case of normal mode, there is point to point and multi point is there. In case of asynchronous, it is a balance mode. So, whatever type of mode you have to select, you have to enter the code corresponding to it. Means if you want to perform this operation, that is SNRM, then this particular code has to be inserted in this U frame, that is specific to U frame only. This is not specific to I frame and S frame. Okay, that this point has to be noted. Next is set normal response mode, that is in extended version. So, this is that is why we have used this SNRME extended version, and it has been denoted by this code, that is 11011. Next is set asynchronous balance mode or disconnect mode. So, this is how, if I want to use the second type of mode, that is the asynchronous balance mode, then we have to use this set asynchronous balance mode and also with the disconnected mode. It is also known as disconnected mode. Now, next is set the asynchronous balance mode extended version. So, we have added a E over here, if you can differentiate these two, and you can differentiate these two by this E also. Next is unnumbered information. This is the information which is unnumbered, means you cannot provide a proper numbering to this. Now, next is unnumbered acknowledgement. This is disconnect or request disconnect. So, this is how you have to show this disconnect by DISC command, and the corresponding code, means you do not have to, you have to just remember that this, what does it mean and what is the full form of these this acronym. So, this is how you have to use that particular type of code for the U frame. Now, next we will see the next part of this lecture is the point to point control, that is a part of the normal response mode, which is used in this HDLC protocol. So, what is point to point protocol? Although this HDLC is a general protocol that can be used for the both point to point and multi point configurations, one of the most common protocol for point to point access is the point to point protocol, or it is known as PPP, that is a byte oriented protocol. Now, let us see, HDLC is a bit oriented protocol. There is a huge difference between bit oriented and byte oriented, not not a huge, in both the cases you have to transmit 1 or 0, but the number of bits that are transmitted in PPP, that is the point to point protocol, that is higher as compared to the HDLC, because in case of this HDLC we have to transmit the bits, and if you remember that 8 bits is equals to 1 byte. So, number of bits transmitted in this case will be higher as compared to this, if you are seeing from the bit point of view. So, that is known as byte oriented protocol. So, point to point protocol is basically a byte oriented protocol. Now, this is the PPP frame format, point to point protocol frame format. If you can see that this is 1 byte, it means 8 bits of information will be transmitted in flag, then 8 bits of information will be transmitted in this address which is fixed, which is shown by all the one. Then 8 bits of information or 1 byte is being transmitted in this control information, then 1 or 2 bytes will be transmitted in this protocol, then it is followed by the payload. Now, payload is basically variable and it is nothing, it is the original data that you want to transmit. So, that is why it is written over here variable. At one point of time you want to transmit 10 bits, at one point of time you want to transmit 32 bits. I am taking just an example. So, depending on the requirement, this payload number of bits or the bytes will be going to change, the size of that will be changed. Now, next will be the FCS. FCS is the frame check sequence, it can be of 2 or 4 bytes, and last one is the flag. Flag is again it is a 1 byte of information. So, if you can see that in this point to point protocol, if it has begin with a flag, then it has ended with a flag again. So, that is a point to point protocol. Now, next is the transition phase. So, this flow chart you can say that this is a transition phase, that how the transition will take place. Now, it will starts from here. This is the establish, you have to establish a particular transmission, then options agreed by both the side. Both the side means when I have started this DCN, I have discussed about the 5 components of communication are there, and one of the component is protocol. Protocol is a set of rules that has to be agreed by both the transmitter and receiver. If one of the user will not agree on that particular protocol, then the proper communication will not take place. Let us say if the first person wants to transmit the information in a particular language and the second person do not understand that language, then how that communication will take place. So, that means the protocol, the idea behind this protocol is very important. So, this is how you have to establish, then options agreed by both the sides will have to be checked, then authenticate, and authentication successful is there. If the authentication is successful, then the network will be formed, and if authentication sometimes we do not require any authentication, then that can be done using this. If the authentication is not required, then we can say that after the establishment the network will form automatically. Then this has been followed by this network layer configuration. It will can be open or it can be an open or it can be closed. Then if it is the information transmission will take place correctly, then it will be done and it will be terminated. And if somehow this authentication is not successful, then also it will be failed, the connection that has been about to establish, it will not establish and it will be terminate. Then carrier drop is there, and then you can see over here, then the connection the network that has set up will be dead, or you can say that the proper information will not take place. So, this is how this transition phase will work. Now, next is the LCP packet encapsulated in a frame, that how this LCP packet will be encapsulated, or how you have to insert that particular LCP packet in this frame. This is headed by a flag, then address and control, this is common, and FCS and flag is also common if you remember. Then you can see that this payload or padding. Padding means if you want to add the redundant bits for checking at the receiver side, or if you want to encrypt the data, then you have to add the PN sequence. So, that is known as padding. Padding is nothing, it is the adding of bits at the end of the particular device, at the end of the sequence or at the beginning of the sequence. So, that is known as the padding. So, this payload and padding will be there. So, this is of variable length, you know it. So, this consists of code, it consists of ID, it consists of length which is of 2 bytes, these are in bytes, and this is the main information that you want to transmit, that is the information. Now, if you see that if I want to transmit 4 bits of information, and along with that 4 bits of information, how many types of data I have to enter. I have to enter the flag information, I have to enter the address control, then this will cover the header part, and this will cover the trail part, trail bits, and this is how the frame will be formed. So, this is the way if you want to add the data, if you want to transmit the data, you have to add this much of information along with your data. Now, this is the LCP packet table which has different codes. This code you can see that this is written over here. If you want to see the code, this one. So, any of the code you can use corresponding to the packet type or the description that contains the list of proposed options and their values. So, you have to use 0 cross 0 1, then accept all the options that are proposed, you have to use the code that is 0 cross 0 2. So, this is how you can see that up to 9 it is written over here, then hexadecimal is used because 1 0 there is no such number is present, 1 0 or 1 1, then you have to use A B C D and so on, the hexadecimal representation. So, this lecture is all about the HDLC and point to point protocol and how the frame has been formed in this HDLC part. These are the references that you can go through. Thank you.